Hello and good afternoon to all of you. I hope all of you are doing well and all of you are in good health. In today's class, moving ahead, we will try to seek answers for the 5 important questions that we had identified in the previous class. The questions are: what is an operating system? Why is an operating system required? Where is an operating system used? When is an operating system used? And what are the various types of operating systems that are deployed in different deployment points in order to realize certain business? To start with, let us discuss what is an operating system. As we have learned in the previous class, there can be various peers of communication. So here, user and computer hardware are the peers of communication. So in order to enable user to interact with the computer hardware, we need an operating system. So operating system is a program that acts as an interface between user and the computer hardware. In addition to that, operating system abstracts all the internal complexities involved in hardware management from the user. So, to the user, the hardware appears to be a black box that takes in input values and generates certain purpose-specific output. Now, this abstraction is done by the operating system. So, the operating system receives the request from the user. The operating system utilizes the hardware in order to perform the operations related to the request sent in from the user. The operating system receives the response and then further communicates the response to the user. So, the overall objective of the operating system, as known, is to create a suitable environment where the user can interact with the computer hardware without having to know about the internal complexity involved in hardware management. So, user sends in a request to the operating system sends the request further to the computer hardware, gets the operation performed, and then receives the response and then communicates the response back to the user. Now, in addition to the received of request and delivery of response, operating system, in addition to that, should also address to these 12 important aspects. These are process management, file management, error handling, coordination, security management, I/O device management, memory management, which includes secondary storage management and main memory management, job accounting, controlling, network management, and user management. So in addition to whatever we have learned, our operating system is expected to manage all of these 12 important aspects. It is also to be known that various operating systems are rated based on their ability to manage all of these 12 important aspects. Now let us elaborate on what further. Now, what is an operating system? So operating system is a program that manages all the interaction between the user and the computer hardware with the internals of the system completely abstracted. Now, as we have learned that a operating system is a program that acts as an interface between the user and the computer hardware. So it's capable of managing all the interaction between user and the computer hardware with the internals of the system completely abstracted. So without having the user know about how the internal complexity of the hardware system is being managed. Secondly, an operating system is a program that manages all the requirements of the application programs with interactions established through defined application programming interface. Now, this is one important action or function that operating system performs. It manages all the requirements of the application programs with interactions established through all the application programming interface associated with the individual application programs. So here, operating system should be capable of letting the application program make use of the computational resources that is computational memory and a computational capacity of the computer system in order to perform operations. So this is the second activity, important activity that operating system performs. Thirdly, operating system is a program that manages all the user's requirement with interaction established through defined user interface. There can be different types of user interface, but it is expected that every operating system has a sound and a stable and uniform set of user interface which a user can use in order to perform certain purpose specific operations. So there are different types of user interface an operating system can have. An operating system can have a command line interface, as in case of DOS, or it can have a graphical user interface, as in case of Windows Express Edition. All of these user interfaces basically allow the user to perform operations uniformly and in a standardized mechanism. So it is always expected that a operating system has a very consistent user interface that can be used in order to perform operations. Now there are several goodness characteristics that a user interface should exhibit in order to make it usable. Firstly and foremost, a user interface should be consistent. So the set of commands should be consistent. Secondly, it has to be uniform. Thirdly, it has to be attractive. Fourthly, it has to be usable. Fifth, it has to be metaphor based. Sixth, it has to have a very good error return convention. So these are some of the goodness criteria that a user interface should exhibit. But here for now, just remember that a operating system should be able to manage all the user's requirement through a well-defined user interface, may it be a command line based interface or graphical user interface. So from the above 3 points, we can make out, or we can generalize that operating system is a program that is capable of managing all the operations. It may be either user-initiated operation or system-initiated operation. So operating system is a program that manages all the operations. It is a program that is supposed to provide or create suitable environments for the program to perform operations. Because until and unless a suitable environment is not created, computational processors will not be able to perform operation. So it's very important for an operating system to create or provide suitable environment for the computational processors to perform operation. Thirdly, an operating system is responsible for allocating resources. Now, there can be different types of resources, computational resources that may be allocated to a process. For an example, computational memory is a type of resource. CPU time is a type of resource. Access to the system buses is a type of resource. So the operating system is responsible for allocating. Rather, we can say it's effective allocation of resources to all the programs and eventually execution of the program. So an operating system is a program that manages all the operations, provides suitable environment, allocates necessary resources, and efficiently manages it so that all the programs can execute in a convenient, efficient, and optimal manner. So this is the overall objective of using an operating system. This is what an operating system is expected to do. In addition to that, an operating system is also expected to provide networking services. So, for example, an operating system should be capable of making a node of computer system interact with other nodes that are there in the computer network and collaboratively realize a business objective. So, these are additions to the additional capacities that we want operating system to exhibit. So, we want operating system to to work with other systems that are there in the network and collaboratively realize a business process. And in addition to that, file sharing is also an important capability. So an operating system should be capable of facilitating resource sharing or data sharing amidst the nodes that are there in the network in order to realize certain business processes. Now, networking and sharing resources are aspects of operating system that focuses on enhancing interoperability of the operating system. So these are some of the important reasons or these are some of the important aspects that tries to address to what an operating system is all about and what an operating system does. So in a nutshell, again, an operating system is capable of managing all the interaction between the user and the computer hardware. It's capable of managing interaction between application program where interaction takes place through a standardized API. It manages all the user interaction through a well-defined set of user interface, may it be command line interface or graphical user interface. So in a generic context, we can say that operating system is a program that manages all the operations, creates suitable environment where the operations can be performed. It allows for resource allocation, that is allocation of memory, allocation of computational time, allocation of access to system bus, so that the programs can execute in a convenient, efficient and optimal manner. To add to that, an operating system is also expected to have ability to network with other systems that are there in the computer network, to work collaboratively in order to realize certain business, and to facilitate file sharing to enhance interoperability aspect. So this is what an operating system is all about. Now, moving ahead, let us try to understand, why do we need an operating system? As expressed earlier, operating system is a program that provides a stable platform for the applications to execute. It's very important for all of us to understand this important role of operating system. Operating system provides a suitable environment or a uniform platform for all the application programs to execute. Now, applications may be either user-initiated application or system-initiated application, but operating system should provide a uniform platform to all the applications. Now, providing uniform platform basically refers to enabling the application to perform these set of sub-activities, which are activity initiation, providing environment, resource allocation, execution, coordination and control, operation and scheduling. So as highlighted in the first class, we have said that operating includes set of sub-activities. So all these set of sub-activities that were highlighted when we discussed operation should be facilitated by the operating system. So to recall it, an operating system should be capable of creating, preparing, initiating, allocating resources and its effective management, scheduling, controlling, coordinating, executing, handling exceptions, and eventually terminating business processes. So an operating system is expected to provide a suitable and a uniform platform to perform all of these activities. An operating system is expected to abstract all the internal hardware complexities from the user. So users are concerned with performing business processes using computational system. Users are not concerned with how the computational system performs operation. So the second important reason why we need an operating system is to abstract the underlying hardware complexity from the user while performing business operation. So how does it do that? It does it by establishing interaction through a standard set of APIs only. So you have a set of application programming interface only through which interaction is made possible between an application program and a computational resource. So an operating system is capable of facilitating that. So an operating system is capable of abstracting all the internal hardware complexities from the users by allowing interaction only through a set of standardized APIs. The third important reason why do we need an operating system is coordination. Now, operating system specifies the protocol to be adhered to whenever the processes interact with each other. So there has to be certain decorum or conduct maintained when interaction takes place between different processes. So that is one of the important role that operating system performs. So it performs proper coordination between various processes when interaction takes place between them. It also defines the various ways in which the interaction may be established between different processes. For an example, interaction may take place through shared memory, interaction may take place through remote procedure call, interaction may take place through API, interaction may take place through remote method invocation. So there are different ways in which interaction may be established between communicating processes. But it is the role of the operating system to define how interaction takes place between different processes. Now, the next important reason why we need an operating system is because an operating system is supposed to express its services as a set of consistent user interfaces. So an operating system offers user interfaces through either command line interface or graphical user interface. So user interfaces are basically portals of communication between the user and the operating system. So one of the measures how we judge the suitability of the operating system is the definition of the user interface. So every operating system, no matter what may be the level of complexity, it is expected to have a very consistent, uniform, usable and attractive set of user interfaces. So this is one of the reasons why do we need an operating system, right? To have a set of consistent user interfaces to which a user can interact in order to do certain business. Now, the next one is managing I/O devices. Now, there can be or there may be different types of I/O devices that may be associated with the computer system. So, operating system is required in order to control and coordinate activities of all the I/O devices that are associated with it. So, operating system is used for controlling I/O resources and its allocation to the user or program, promoting effective and efficient utilization. So, for an example, monitor, keyboard, printer, memory, say for example flash memory. So these are all I/O devices. So in order to promote effective and efficient utilization, we need an operating system. Moving forward, we need an operating system to promote multitasking. Now, multitasking basically refers to an ability of the processor to perform multiple operations at a given point in time. So multitasking basically refers to the ability of a processor to perform different operations at the same point in time. But whenever multitasking is being performed, it's very important for the operating system to adapt to efficient algorithms that are capable of managing memory and CPU time between the various processes. So that is an important role that the operating system should perform. Efficiently manage memory utilization and CPU utilization by the various processes that are being multitasked. Multitasking, in this case, so operating system manages the memory, enabling multiple programs to perform operations in their own space. So this is what we have been talking about. Now, the next important aspect, why do we need operating system, is processor management. Now, processor management basically refers to allotment of CPU time to different processes, which is referred to as scheduling. Now, in a system, there can be one processor or there can be more than one processor. So depending upon the type of architecture being used, there can be a single processor or there can be more than one processor. Now, it's the role of the operating system to efficiently schedule the programs or the processes over either a single processor or a set of processors. So that is called as processor management. So operating system is responsible for assigning processes to various processors that are there in a computer system. Now, we have learned about various scheduling algorithms in the past. 7 examples: shortage of first is one of the scheduling algorithm. Round robin is another scheduling algorithm. And we have priority scheduling. So that is another scheduling algorithm. So there are different variants of scheduling algorithm that can be pursued in order to assign the processes to the processors that are there in the computer system that is being used. So this is one of the important role that operating system plays. Now, the next important reason why we need operating system is device management. Now, device management basically refers to managing communication between various devices that are there in the computer system. Now, different devices that are there in the computer system may not be capable of operating at the same speed. What I intend to say is that different devices in a computer system operate at different speed. So, for an example, memory and the central processing unit may operate at different speed. Central processing unit and I/O devices may operate at different speed. For an example, the speed at which the data is being sent by the central processing unit to the memory device may be considerably higher to the rate at which the memory device is capable of receiving the data. So in such situation, we need an efficient device management skill. So an operating system is expected to have such device management skill that is capable of managing communication between peers of computer system that operates at different speed. So for an example, we have a concept called as buffering. We have concept called as spooling. For example, associated with every printer we have spool. So spool is capable of queuing up all the jobs that are assigned to the printer, and what printer does, printer performs operation at its own speed, selecting the job that is placed in the spool. So here, the information that is being communicated between device and the printer is not lost, but rather stored in a spool, that is a pool of memory, and as and when required, the printer selects a job from the spool and then performs that particular task. Because the rate at which a printer may print and the rate at which the document may be submitted to the printer may be completely different. So in order to manage communication between a slow printer and a fast device, we need a printer spool. Now likewise, we have buffer placed in between a high-speed processing unit and a low-speed memory unit. So for example, the rate at which the data is written onto the flash drive may be considerably lower compared to that of the rate at which the data is being produced. So here what we do is we place the data into the data buffer, and from the data buffer the data gets communicated to the storage device. So the device controller that is associated with each and every device is responsible for managing the buffer or the spool. Again, I repeat it, the device controller that is associated with each and every device is responsible for managing the spool and the buffer. So spool and buffer is a concept that is used in order to synchronize communication between devices that works at different speed. So elaborated here is buffering and spooling. So operating system uses device controller to move the data from the input device to the input buffer and from output buffer to the output device, right? So this is the way how interaction takes place. So from the processor to the memory to the buffer, buffer to the device. From device to the buffer, buffer to the memory, memory to the processor. Because memory, processor and the device works at different speed. Now likewise spooling. So here what we have is we have a memory allocation at the hard drive done that will keep track of all the jobs that are being assigned to a printer or to a resource attached, right? So whenever the resource performs operation, it selects the job from the spool and performs the operation. So the spool is exhausted at the speed of the resource, whereas the spool is populated at the speed of the device. So that is the way how it works. Now likewise, moving forward, the next important reason why we require operating system is memory management. Now, there might be different types of memory that may be associated with the computer hardware. So, if an example, you have CPU registers, you have cache, you have different variants of cache, you have internal cache, you have external cache, right? And then you have main memory, then you have secondary storage, then you have a flash drive, and so on and so on and so forth. So there are several types of memory that may be associated with the computer system. So operating system should be capable of efficiently managing the utilization of the memory systems that are there associated with the computer system. Right? So operating system manages memory utilization through technique called as partitioning and virtual memory. Now partitioning basically refers to a mechanism of dividing the memory into identifiable slices, where slices are being assigned to programs. Again, I'll repeat it. Partitioning basically refers to a mechanism of creating slices of the memory and then assigning the memory to the programs, or it implies assigning the or storing the programs onto the individual slices. Now, partitioning basically refers to a mechanism of dividing the memory into partition, equi-sized or of variable sized, accordingly to a number of programs in the memory. So many number of programs are to be executed by the central processing unit. So what you do is you partition the memory amongst the program. Now the next one is called as virtual memory. Now in situation, there might be situation that the program may be bought into the main memory from the secondary memory as a whole. And in situation, if it cannot be bought as a whole, what we do is we divide the program into chunks, and as and when required, we bring the chunk into the main memory, execute it, and then continuously repeat that particular process. Now that is the way how program is executed. So it is important for all of us to know that any program that is to be executed, wherever it may be located, has to be brought to the main memory. Only then the central processing unit can execute that particular program. So that is the way how execution takes place. So wherever the program is located, bring the program into the main memory and then execute the program. But there might be situation where the program can be bought as a whole, or it may not, the main memory may not be able to fit the entire program. So in situation, if the program is larger, what we do is we divide the program into chunks, bring the chunks into the main memory, execute it, and then repeat that particular process unless the entire program is executed. So operating system allows for execution of larger program. The program is executed even if the complete program cannot be loaded in the main memory, leading to efficient memory utilization. So that is the way how execution of larger program is done. So this is one of the important role that operating system performs. Now the next important task operating system performs is file management. So operating system efficiently manages the files, folders and directory system that are on a computer with associated privileges. So this is one of the important role that an operating system performs. It neatly organizes various files, folders and directories that are there in the storage device, so it can be easily and uniformly accessed. In addition to that, an operating system also associates privileges with the various files, folders and directories. Privileges basically means the access rights. So for example, whether it is read protected, write protected, or whether it's hidden. So it allows you to associate several different types of attributes with the file, folders and directories. So file management is one key aspect of operating system. Now the next important aspect of operating system is security and reliability. So one of the measures how we judge the ability of the operating system is its ability in ensuring security and reliability. So how we can ensure security is by having an operating system that prevents unauthorized access to data and computational resources that a computer system has, and by providing sustained services. Irrespective of whatever may be the state of the operating system, it should be capable of providing sustained services. Even if an operating system enters into a false state, the operating system should be capable of recovering from the false state and resuming active services. So these are some of the important reasons why we need operating system. So in today's class, we have learned about what is an operating system, what are the functions of the operating system. We have learned that operating system manages all the interaction between user and the computer hardware by abstracting all the internal complexities. We've learned that it manages all the requirements of the application program. It manages requirements of all the user-initiated program, which implies it is capable of managing all the operations, creating suitable environment, allocating resources, and execution of program in convenient, efficient, and optimal manner. Additionally, a operating system is capable of networking, should be capable of networking with the other computers that are there in the computer network in order to collaboratively realize business process. It should be capable of sharing files. So these are the aspects that basically enhances interoperability of the operating system. Then we moved on to why. We've learned why do we need operating system. So operating system provides a suitable and uniform platform. It abstracts all the underlying hardware complexity. It facilitates proper coordination. It provides consistent set of user interfaces. It helps in managing I/O devices. It helps in multitasking. It helps in process management. It helps in device management. Where we have learned that how buffering and spooling helps the devices that operates at different speed communicate with each other. Then operating system helps in efficient memory management, where we have learned the significance of partitioning and version memory. Operating system helps in file management, and eventually operating system helps in promoting security and reliability. So in the subsequent class, we will learn where and when do we need operating systems. So for now, we'll call it a day. Thank you very much and have a nice day.